This is the most exciting new technology project I've ever had in my life.
Nanotechnology is a comparatively new field of science. It deals with controlling matter on the scale of nanometers in order to create state-of-the-art materials.
The science community has just in the last decade or so developed the capability of actually looking at and testing and understanding materials in the nanoscale range.
To understand the world of nanotechnology, one needs to get an idea of the scale involved. A nanometer is 1/1000th of a meter. The head of a pin is about 1,000,000 nanometers wide, and a human hair about 100,000 nanometers wide.
The biggest thing is you can't see it. You can't see it with the visible eye, you can't see it with a microscope, you can't see it with light. It takes an electron microscope, and it takes the best electron microscopes to find these things and to tell us what we're looking at, what we've made.
The Forest Service's research branch has been instrumental in nanotechnology studies, in part because some nanomaterials are comprised of cellulose, a component of wood.
Basically, one way to think about it is a very ultra-refined paper. You break it down to its tiniest elements, and we get these crystalline forms of cellulose.
Cellulose nanocrystals are extracted from native biomass, in this case trees, by Forest Products Lab. And you just basically dissolve the rest of the wood, other than the crystalline cellulose, away in acid, collect the crystals. They're renewable, non-toxic. You can have as much as you want from sawdust and waste biomass if you want.
Creating markets for wood is imperative in our ongoing restoration efforts. We must find uses for the millions of diseased, damaged, and small diameter logs now heavily overstocking our forests.
It's kind of amazing when you think about a tree. They can grow 370 feet high in the air. That's taller than the Statue of Liberty. That's a pretty amazing structure. It can withstand rain events, wind events, earthquakes, hurricanes. A tremendous amount of strength in that material. And what we do is we actually break that tree down to its ultimate crystalline stages, where we get all that strength and we get it in a very compact way. And so then we can take the strength and bring it to all kinds of different materials.
Cellulose nanomaterials are as strong as steel, but 5 times lighter. Potential uses include car panels, ballistic glass, synthetic armor, and even medical applications.
One of the things people have looked at is building connective tissue, like replacement tendons, primarily because cellulose is very, very compatible with the human body in general. There's also an application for food coatings to delay the decay rate. Almost half the fruit and vegetables that are produced end up going to waste. The idea that we could maybe halve that number, this is huge. This is absolutely huge.
The Forest Products Lab has been working with a group of partners to test practical uses of this technology.
All of these groups coming together to really try to take something from a laboratory study and really move it into commercialization, where it can really have an impact on people and on communities.
One such product tested was concrete.
So what we've seen today is we've seen the first, that we're aware of, the first addition of cellulose nanocrystals to concrete at a truck scale of anywhere in the world.
Cement's this weird thing that you want it to flow, so you want to add a lot of water, except that makes it weak. You want to add very little water to make it strong. The CNCs enhance the hydration so that you can ultimately add less water to get a higher strength cement.
As they mixed that together, it was then transported over here to the Wave Lab, where we were able to actually start to make different types of samples.
The whole objective is to bring innovation to the forest products industry. By using a forest product, what we're doing is creating markets for forests.
Rather than lab scale, we want to be dealing with bridges and roads and precast and big stuff that people actually use.
The research division of the USDA Forest Service has been working with this promising new application of wood fiber, which will help restore our national forests into the future.
It's a game changer. It's a game changer for the wood products industry, and we think it's going to be a game changer for the materials industries.